Okay, today I'm going to recap our notes on simplifying nth root radicals. So to start off, there's just a warm-up to practice changing improper fractions into mixed numbers or whole numbers. So if you know how to do that, then just go ahead and pause the video and fill that in and then come back and check to see if you got them right. Okay, if you don't know how to do it, then I will remind you. Okay, so it's always going to be the numerator divided by the denominator. So 4 divided by 2 is 2. 11 divided by 2 is not a whole number. So if you can do it in your head, awesome, and say 11 goes, or 2 goes into 11 5 times with 1 left over, 5 1/2. If you can't do it in your head, then just do a little division problem right here. Put your 11 as your dividend, your 2 is your divisor, and then just divide. So 2 goes into 11 5 times. 2 times 5 is 10. Subtract and you get 1 left over, and then that's your numerator of your mixed number. And your denominator stays the 2. 9 divided by 3 is 3. 23 divided by 3 is not a whole number. If you can do it in your head, you would say 23 divided by 3 is 7 with 2 left over, so 7 2/3. If you can't do it in your head, then you just make a little division problem. 23 is your dividend, 3 is your divisor, and then 3 times, how many times does 3 go into 23? 7 times, and you get 21. Subtract, and you get 2, so that's your remainder. So you just would, that becomes your numerator, and your denominator stays the same. 21/4, that's not a whole number. You can do it in your head to say it goes in 5 times with 1 left over, or you can make a division problem. And 4 times 5 is 20, subtract, and you get 1, so 5 1/4. And then lastly, 22/4. I mean, if you're doing it in your head, you probably know that that is 5 2/4 because it's just one bigger than the last problem. Or it simplifies, and you always want to simplify because it'll make what we're going to do today goof up if you don't. Okay, so simplify that. Now, if you can't do it in your head, then again, just make a division problem. 22 divided by 4, and you know from the last problem that it goes in 5 times to get 20 with 2 left over. So that's the 5 2/4, which simplifies to 5 1/2. Alrighty, so if you're coming back on now to look and check your answers, there they are. All right, now, to save time, we filled in a list of perfect squares, perfect cubes, and perfect fourths for you. That's the first 20 perfect squares, the first 10 positive and negative perfect cubes, and the first 10 perfect fourths.
Or Rachel Moore, please call 7403.
Okay, sorry about that. All right, now just a little bit of vocabulary. We've only worked with square roots, so now we're going to work with cubed roots and fourth roots also, so you just kind of need to know this vocabulary. So the little number that I'm going to highlight right now, that is called the index of the radical. I'm highlighting now is the radical sign. And then the number that is inside that I'm highlighting now in purple, that's called the radicand, okay? So the number inside is the radicand, the sign is called the radical, and the little number that tells you what root it is called the index. Now, if there's no index, like in A right here, so if there's no index, that means it's a square root, okay? So you can put the 2 if you want, but you guys already know that if there's nothing there, it's square root. All right, and that would be an index of 2. All right, so the first problem, A, is just a review from earlier in the year. Taking the square root of 48, what you would do is you would look up at your perfect square chart, and 48 is not on the list. If it was, it would be right here in between 36 and 49. So since it's not there, you want to find the biggest perfect square factor of 48. 48 actually has two perfect square factors. You want the biggest one. So what you should do is just do 48 divided by 36 and see if it works, and it doesn't. Then do 48 divided by 25 and see if that works. It doesn't. And then do 48 divided by 16, and that does work. So that's what you're going to do. You're going to rewrite this as square root of 48, oh, I'm sorry, excuse me, square root of 16 times 3, okay? And then you can simplify this by saying the square root of 16 is 4, so that gets out of the radical, and then the 3 stays in. So your simplified answer for square root of 48 is 4 square root of 3. Now, cubed roots work the same way. You just have different numbers that are cubes. So this is 5 times the cubed root of 48. So looking up at your cubed root list, if 48 was a perfect cube, it would be right here in between 27 and 64. Since it's not there, you want to try the numbers less than that in order. So first we would do 27. 48 divided by 27, that's a decimal, and then we would do 48 divided by 8, and that is 6. So we're going to break this into 5 times the cubed root of 8 times 6. And then the cubed root of 8 is 2, so that gets out of the radical, so it's 5 times 2, and then radical, or cubed root of 6. So that final answer would be 10 cubed root of 6. So that is the simplified answer for 5 cubed root of 48. All right, notice that the next one has a negative under the radical. This is not going to be an imaginary solution because this is a cubed root. You can multiply 3 negatives together and get a negative. So the odd roots, when your index is an odd number, okay, remember this is your index that I just highlighted in yellow. When your index is an odd number, then you can have negatives under the radical and still get a real number solution. So, looking at this, we're going to look up at our cubes, and negative 250 is not, whoops, excuse me, negative 250 is not on our list. If it was, it would be right here in between negative 216 and negative 343. So since it isn't, we're going to divide by the numbers less than that. So negative 250 divided by negative 216, decimal. Negative 250 divided by negative 125, bingo, that one works. It's 2. So we're going to rewrite this as the cubed root of negative 125 times 2. And guys, you want to always get the negative out of the radical and leave the positive number inside. So, cubed root of 125, and again, you can use your calculator, or all you have to do to see what it is look at your list. So, this is 1, 2, 3, 4, 5. This is the 5th perfect cube. So the cubed root of that is 5, okay? Or you can use your calculators and do the cubed root. You could use Desmos on here. I can show you real quick. It's actually easier than your calculator. So if you use the scientific Desmos, you just would use, let's see if I can point to it. This button right here, can you see it getting dark? Here I'm holding it down, it got dark. So it would be that button. And then it gives you a place to put in your index, which in this case is 3, and then put in your radicand, negative 125, and you get your negative 5. Or again, you can just count on your list of perfect cubes to get the negative 5. So this is negative 5 gets out of the radical. And inside the radical is the 2, so 5 cubed root of 2. Okay, now we got a fourth power. So we want to look at our perfect fourths. And 2,592 is not on the list. It would be right here if it was. So we got to try the numbers less than that. So 2,592 divided by 2,401 doesn't work. So 2,592 divided by 1,296, that does work. So we're going to rewrite this as 5 times the fourth root of 1,296 times 2. So use your calculator or count on your list, and you would see that this is the 6th perfect fourth. So the fourth root of that number is 6. So we would do 5 times 6, and then fourth root of 2, so 30, fourth root of 2. And again, if you need to use your calculator, you're just going to do the button that has an index of n with a radical. It's right here in the middle. And then you're going to put your index in, which in this case is a 4. You're going to put in your 1,296, and you get 6. So the simplified answer for 5, fourth root of 2,592 is 30, fourth root of 2. All right, now you're going to see something really, really radical. And this is how we can take something that is in radical form. So here it is in radical form. And we can change it into exponent form. So the nth root of a can be written as the exponent form, a to the 1 over n power. And then just to show you it with so that it can be any numbers, here it is, the nth root of a to the m power. And that m power can be inside the radical or outside with parentheses. It still be the same thing. The nth root of a raised to the mth power would get written like this, a to the m over n power. So notice that the exponent that's with your radicand, the m, that's always going to go on top. And then the index, the n, that's always going to be the denominator of your exponent, okay? So I think you're going to get the idea of why we started our warm-up with simplifying fractions, since now we're going to deal with fractional exponents. So using that idea to simplify, what we would do, and remember, if there's no index, remember this, we wrote right here, if there's no index, the index is 2. It's the square root, okay? So just for how we're practicing this fractional exponents idea, let's go ahead and put our 2's in anyways, just to make this more clear. Okay, so now just looking at what we have right up here, so let me show you again. So looking at this that I'm circling, we can see that this number here, I'm doing the same color, is going to be the denominator of our exponent. And then this number here or here is going to be the numerator of our exponent. So I'll go ahead and color code it the same way. Now, using this idea right here, putting your exponent over your index to make a new exponent for our variable, we would have this as x to the 2 over 2, and that simplifies to 1, so this would be x to the first, or you know that we can just write that as x. Okay? So see what happened here. Here's our index. Here's our exponent. All right, so same thing over here. X to the 4 over 2. Notice where the things went. There's where the 4 went. Here's where the index went. Okay? Then simplify that fraction, and you get x to the second. All right? Do the same thing here. X to the 6 over 2 power would be x to the third power. Now, this one's not going to come out as a whole number because 2 doesn't go into 11. There's a leftover. There's a remainder. So if we write it as x to the 11 over 2 power, or 11 halves, you could say, if we simplify that, we did that up at the top. We did 11 divided by 2 up here at the top. And we got 5 1/2, okay? So if we think of this as x to the 5 1/2, which we're not allowed to do that, this is just a shortcut to help you, then that tells us that this part is x to the 5th, okay, just like over here. But then that 1/2 part that's left, that's going to be put back into a radical. So that would be square root of x to the 1st. Or you can just write it without the index and without the 1 as x to the 5th times square root of x. Okay? So let me just show you that again. So this part is right here, and the x to the 1/2 part is right here. We have to rewrite it back in radical form. All right, so let me do the cubes here. So you do the same thing. This is going to be your numerator. The exponent of your variable is going to be your numerator. And the index is going to be your denominator. In this case, your denominator is going to be 3 because these are all examples of cubes. Okay, or third roots. So following the pattern, this is going to be x to the 3 over 3 power, which would be x to the 1st, or x. This is going to be x to the 6 over 3 power, which would be x squared. This one's going to be x to the 9 over 3 power, which would be x cubed when you simplify. And now we're going to get to the ones that you're going to have a radical in your answer. 16 divided by 3. 3 goes into 16 5 times with 1 left over. So this is going to be x to the 5 1/3. Okay? So remember what I just showed you on the other one, on the squared ones. This part is just like this. There's no radical. So x to the 5th. And then this part has to be x that's under the radical, the part that's left over. So cubed root of x to the 1st. And you don't have to put the 1 there, but you can. But just notice that the numerator is going here. The denominator is your index. Okay, let's do another one. 3 is not a factor of 23, so we're going to have to figure out the mixed number. So 3 goes into 23 7 times with 2 left over. So 7 2/3. So that means this would be x to the 7 2/3, but we're not allowed to do that. So we've got this part that's x to the 7th, and this part that's x to the 2/3. So x to the 7th is outside the radical, and then we've got a cubed root with x squared on the inside. And notice where this is going, just like from our rule, the numerator of your exponent is going inside with the radicand. The denominator of your exponent is the index of your radical. Okay? All right, last one, fourth powers. So you should be getting pretty good at this now. So this would be x to the 4 over 4, which would be x to the first, x to the 8/4 power, which would be x squared, x to the 12/4 power, which would be x cubed, x to the 21/4. Ooh, that doesn't simplify. Did we do that one up at the top? 21/4? Yeah, right here. We got 5 1/4. So you don't have to do it again down here. So this is x to the 5 1/4, which actually means x to the 5th and then the 4th root of x to the 1st. You can put the 1 there or you don't have to, because remember, what happens here is this goes with your variable, with your radicand, and the 4 is the index of your radical. All right, this one we already did up at the top too. So x to the 22/4, we did that up here in our warm-up. 22/4 equals 5 1/2, and you want to make sure you do 5 1/2. Don't do 5 2/4 because then it wouldn't be completely simplified. So we do x to the 5 1/2. So that's x to the 5th outside of the radical, and then a square root. So you don't have to put that 2 there. You can if you want, or you can leave that off. And then this would be square root of x to the 1st, which we don't have to necessarily write that. So let me show you that again. You could put a 1 here and a 2 here to represent square root and then the power of your radicand. Or since it's square root, you don't have to put it. You can just write it as x to the 5th square root of x. Okay, this one we did not do up above, so we'll go ahead and do it. But you probably can do it in your head since it's only one more than the last one. But anyway, so this is 5 with 3 left over. So this is 5 3/4. So this would be x to the 5 3/4. So this part is our whole number part. So that's out of the radical, x to the 5th. And then your radical, here's your index, and then here's your power of x. Okay, so x to the 5th, 4th root of x third would be the simplified version of the 4th root of x to the 23rd power. All right, now I'm just going to do 4 example problems. And then I will be quiet and you guys can work on your practice. If you need help with the practice, I'll put a video on tomorrow that has me going through the practice problems if you need help with any of those. Okay? All right, so tomorrow all you'll have to do is those practice problems. All right, so here's the first one. Now this is kind of weird because we're putting everything together now. We've got the number and the variables. So we're going to still simplify the number part like we always have, square root of 32. And we're going to write that as 16 times 2. And you just would use your chart or your list to find the biggest perfect square factor of 32. Then we're going to write our variables in exponent form. This is a square root, so that means its index is 2. So when we write it in exponent form, it would be x to the 4 over 2. And then y to the 9 over 2. So now let's simplify. This is going to be square root of 16 is 4, and then the 2 has to stay in. So 4 square root of 2. 4 divided by 2 is 2. So this becomes x squared. 9 divided by 2 is 4 1/2, so y to the 4 1/2. And if you can't do that in your head, then just go over here to the side and do 9 divided by 2. to get your 4 1/2. And so then to rewrite that in radical form, your y to the 4th is the part out of the radical, and then the 1/2 would be square root of y, because y to the 1st is y. So now take everything that's out of the radical and put it out front. 4x squared, y to the 4th. That's going to go outside, 4x squared, y to the 4th. And then the things that are going to go into the radical are square root of 2 and square root of y. So put those together under the radical. Okay? So just look at how I highlighted the things so you can kind of see what goes where. So this, and this go outside of the radical, and then square root of 2 and square root of y go together under the radical. Okay? You can pause it if you need to think this through. All right, next one. So now we've got a cubed root. So we need to look at our cubed root list. 56 is not a perfect cube. If you look up here, it's not a perfect cube. So you got to find the biggest perfect cube factor of 56. And it, in fact, only has one perfect cube factor, 8. So we're going to rewrite this as cubed root of 8 times 7, your perfect cube in the front. Then we're going to rewrite each of our variables in exponent form. So r to the 8/3 and s to the 4/3. Okay? Now, this 8, cubed root of 8, gets out of the radical. Cubed root of 8 is equal to 2. So this is going to be 2 cubed root of 7. These ones, r to the 8/3, we can rewrite as r to the 2 2/3 to help us simplify, and 5 to the 1 1/3. Okay? Now, writing the variables back into radical form, this is going to be r squared outside, and then remember where everything goes. This is your index, the 3 is your index, the 2 is the exponent of your variable, so r squared, so cubed root of r squared. Same thing for the s. I don't know why that's a 5. That's supposed to be an s. Oh gosh. So s to the 1st, and then cubed root of s to the 1st, because here's where these things go. All right, and then the big number, the whole number part, is always what gets out of the radical. Okay? All right, now let's put everything together that's outside. So here's the things outside. 2 r squared and s to the 1st. So that goes outside. 2 r squared s. Then the things that are going to stay in the radical. Cubed root of 7, cubed root of r squared, cubed root of s. So 7r squared s. Okay, you can pause if you need time. If not, go ahead and go on to C. All right, looking up at your cubed root list, exciting news. This is a perfect cube. So that's going to just get out of the radical as a -4. Okay? So we'll hang on to that, and we'll do the rest of our simplifying. So this is going to be x to the 10/3 and y to the 21/3. So bring down your -4, and then 10/3 is actually 3 1/3. So that means you're going to have an x cubed out of the radical and 1x under the radical. And then this is y to the 7th. 21 divided by 3 is 7. So this as a radical would be x cubed and then cubed root of x to the 1st. And you can put the 1 or not put the 1. Just remember, this is your index, the 3, and the 1 is your exponent of your radicand. So then put everything together. Everything outside is, whoops, excuse me, is 4x cubed and y to the 7th, so that goes outside. And then your radical part, the only radical part you have is this. So you just put that beside it, cubed root of x to the 1st, or x. Okay, last example. This is a 4th root one. So look up at your 4th roots, and you'll see 48 is not a perfect 4th, but it does have the perfect 4th factor, 16. So we'll rewrite this as 4th root of 16 times 3. Then rewrite our variables in exponent form. So this would be m to the 8/4 power and n to the 3/4 power. Okay? So, simplifying, 4th root of 16 is 2. And then our 3 stays in our radical. 8 divided by 4 is 2, so this is going to be no radical for the m. That's going to be m squared. And then this one is not an improper fraction. It can't simplify, so we could have just left it the way it was. So we know that this is just the 4th root of n cubed, because there wasn't enough, it wasn't an improper fraction, so there wasn't enough factors of n to get out of the radical. So now take your things that are outside, your 2 and your m squared, and that's going to go out front. And then your things that are under the radical, put them together under one radical to get 4th root of 3n cubed. All right, that's all for the notes. Okay, so try the practice on your own, and if you get stuck, you can always fast forward to that part of my video tomorrow, and I will go through all the practice problems tomorrow. All right, hope you have a good night. See you guys soon. Bye-bye.